Welcome to solverfy.
Okay, so this is a question about stoichiometry in chemical equations. So here it shows the equation which is the sodium silicates react with a hydrofluoric acid, and it's already balanced the equation, and it produces several things. H2SiF6 and plus 2 sodium fluoride and plus 3 water molecules. So the first question is how many moles of the HF are needed to react with 0.3 moles of the sodium silicates? So this is just understanding on the stoichiometry. You can see from the chemical equation, every time you consume 1 moles of the sodium silicates, you are also consuming 8 moles of the HF, which means the moles of the HF or equals to 8 times the moles of the sodium silicates. So now we can just do the calculation, right? You just need to plug in 0.3, so it's 2.4 moles of the HF will be used. And the second question is how many grams of the sodium fluoride form when 0.5 moles of the HF reacts? As you can see, every time you produce 2 moles of sodium fluoride, you are actually consume 8 moles of the hydrofluoric acid. So you actually know that the moles of the sodium fluoride will actually be equals to 1/4 of the moles of the HF. So we can plug in the number, which is 0.0, which is just 0.5. So this is 0.125 more. And ask us about the mass. So the mass of the sodium fluoride simply equals to moles of sodium fluoride times the mole mass of the sodium fluoride, which is 0.125 times 23 plus fluoride, I think it's 17, right? Sorry, it's 19, not 17. Anyway, we can do the calculations here. It becomes 5.25 grams, and that's the mass you need for the reaction. And now let's see how many grams of the sodium silicates can react with 0.8 grams HF. As we already know in the first question, the moles of the HF equals to 8 times moles of the sodium silicates. So the moles of the sodium silicates, which is simply equals to 1/8 of the moles of the HF, which is 1/8 times the mass of the HF. The mass of the HF here is 0.8 grams. And the mole mass of the HF is 42. So it's actually around 1.15 to 4 moles of the sodium silicates. Sorry, it's wrong. This number is wrong. It's actually equals to 1. Actually around 0.0024 moles. So now we can calculate the mass equals to the moles times mole mass, which equals to 0.0024 times the moles mass of the sodium silicates is actually 2 times 23 times 3 times 16 plus the mole mass of the silicon is 28. So it's equals to 0.0024 times 46 plus 48 plus 28. And it's equals to around 0.29 grams. And this is the answer.